Thank you so much for joining, and thank you to 1-2N, Jaideep ji, and team for hosting this event. Right. So I think today I'm going to talk about how it is or how it was to build and ship a product, right? Because very often I've seen a lot of prototypes being built, and I wanted to talk about one full journey from idea to how it is for people to actually use it, right? So in the last 1.5 years, I worked with around 10 companies across all levels. So I worked with them on AI strategy with decision makers on how they can leverage emerging technology, right? And I've also worked with sales and biz dev teams on perception, with product teams on feasibility, because you often have to pull them back to the ground on what's possible and what makes sense for them to do. And I've spent a lot of time with engineers where we've actually built these systems. We have architected them, and we've re-architected their existing systems so that they're more, quote unquote, future proof. So before this, I had co-founded a gaming company. We used to build multiplayer mobile games. And before that, I've done a bunch of other tech stuff, right? And today I wanted to talk about how it is like to build and ship something, some observations, and maybe some mistakes we can learn from, right? There are a lot of mistakes I made, and I think some other people also make similar mistakes, and we'll try to learn something from it. And at the end of this, I would like to spend like 3-4 minutes talking about what I'm building now, because I think it's very relevant to what I'm going to talk about, and I think all of you will like it, right? So around like 1.5 years ago, I transitioned from building games. I'm so sorry. I transitioned from building games to building more technology or building more AI. So from like a more user-facing products to building technology that helps people build products, right? And why I did different story, but when I did that in hindsight, it has been a very interesting journey. But when you're looking forward, it's always scary, right? So one of the first things I did, which is like my comfort thing, is I started building. I wanted to see how it is like to build something in this space with emerging tech and with all the buzz and hype around. I want to see the actual experience of building something, right? So one of the first things I built was this tool. What it lets you do is you can look up any product or software or anything, and it will scour the internet, look through all comments on YouTube, App Store, etc., and tell you what people are talking about it. What do people like? What do people hate? Maybe you released an update and you want to know how it's doing, and you can use this to check your products, your competitor's product, anything. I'm selling the product too much, but I don't care about it. I wanted to know how it is like to build something. Like if a company chose to build something like this for themselves, how hard is it? And how does it look from outside versus how it is to actually build it? The other thing I was getting really interested in was running AI on the edge, because I strongly believe in, see, the thing is, if technology, everyone has access to the same technology, right? What is going to set you apart is your data, your unique understanding of market. And when I say data, it's not just your databases, it is your code and everything else. So and the reason a lot of big enterprises do not adopt AI early on is because of data privacy. Because there's two kinds of companies, right? Companies that say they collect your data and the companies that say they don't collect your data. And it is that one of them is lying. I won't say which one, but one of them is lying, right? So I built an app that can run small language models like up to 4 billion params on your phone, on both Android and iOS. It uses your phone's GPU, it runs offline. Again, the aim was not to build and ship this, it was to understand how it is to build something like it. And so when I was building WAPTA is just what are people talking about? I just code named it like that. I expected I'll build it something like that in like a week, right? All you have to do is collect a bunch of data, categorize it, deduplicate it, and aggregate it. That's it. But it took me over a month to build something like that. Same for offline AI. I thought I'd build it in like 2 weeks because there are multiple runtimes that run on ARM processors, but it took me well over 4 weeks. So what I realized is it is deceptively hard to actually ship something, right? Once you take human out of the loop, it becomes very hard to actually build and ship something like this. So what I started doing next was I also went and spoke to a bunch of people. Ki, aap kya kar rahe ho and what are you trying to do? And most of them asked me the same question back, what should we do, right? Now, there are some AI native companies who know what they want to do, right? But for the vast majority of companies, they had no idea. There was a lot of FOMO. Ki, now that this whole thing is happening, we don't want to get left behind. But most people had no idea what they were going to do about it, how they're going to build something. And then maybe I thought maybe I should take this a step further. So I printed slightly funny or wacky business cards. I printed like 8 different ones of these, and it had stuff like AI won't replace you, but your competitors might. And when I spoke to decision makers, now instead of asking them what they want to do, and when they asked me back, I told them I'll just help you build something, right? So because I wanted to get into the space, I wanted to get my hands dirty. And what ended up happening was I spent the last 1.5 years working with a bunch of companies, helping them go from prototype to production. A lot of those projects are in prototype, but around 4 or 5 of them went to production. And because I became like a consultant, I was able to choose what kind of companies I want to work with, industries, team sizes, even across countries, right? So I worked across different industries. With some companies, I've had a very deep engagement of like over a year. And I've had like smaller consultations with some other companies. And I've been able to choose across problems also. So in perception and understanding, it would mean analyzing text, audio, video, etc. Data infra observability. So they've given, Jaideep ji has given a great example. One more thing we built in this was, there's an automotive manufacturing company, and we help them observe their factories and find out why their OE is low or their operational efficiency is low, etc. Generation, reasoning, and agents, and knowledge systems, right? This seems to be very popular. This is one of the first things that became popular in this space. So let's talk about one example that went from idea to production, and let's see how the journey was, right? So we've been building this for over a year. I think we started last September, and in June, they actually got enterprise clients and people are using it now. So this company was building a workplace assistant. What it means is it's like ChatGPT, but you can ask it to do things across apps. So they support over 30 apps, and you can say something like, find my unpaid invoices on Stripe, get their emails, draft them emails reminding them to pay, and create a ticket on Jira for my customer support team to review and send those emails, right? You can just say it or type it, and it will work across all these apps to get that task done. So, and my job in this was to architect and actually build the thing that does the task, like it gets an instruction and does the task. So this was our first version. It took us like 3 weeks to build it, right? So how this version worked was essentially we had a key vault to store all the tokens for different integrations. So let's say you want to connect to Teams, Gmail, etc. For each user, we would store those things. And then we were individually maintaining some integration methods. So maybe you want to maintain 10 actions across Jira, 5 actions on Gmail, Outlook. So we would individually maintain those, and we would use structured responses. So we would just ask an LLM ki user ko ye karna hai, kaise kare? And the LLM would give us like a structured response ki use these tools, use this, use that, and then we would give it API ke specs, and it would tell us what APIs to call, and we would call it, right? Now this worked well up to like 10 tools, 12 tools. After that, it became hell. And also this was like almost 1.5 years ago. And at that time, I think we were dealing with a GPT-4o or something, right? In the next iteration, we replaced structured responses with function calls. They are essentially the same thing, but function calls let LLMs call tools themselves, right? But our next big problem was these integration methods. It was becoming very tedious to maintain. And this is solved problem, right? We didn't want to solve the solved problem again, and we were a small team, like 13, 14 engineers. So we replaced those integration methods with an iPaaS. So what an iPaaS is integration platform as a service. So if you used something like Zapier, N8N, Nango, or integration app, they can all pass as an iPaaS. So what they let you do is they will maintain connections to all these apps, Teams, वगैरह वगैरह. They'll be the key vault, and all we have to do is tell the iPaaS किस app में क्या करना है, right? Now our flow became very simple. We just user sends something, we ask LLM ये सब tools है क्या करना है, LLM कुछ बताता है, हम iPaaS को बताते हैं, right? We just became like this middleman. So we started calling this workflow orchestrator, where we're just doing the right things, like converting natural language to some structure and giving it some structure. The big problem with iPaaS is they are not really meant for, let's say, AI वगैरह. They were meant for you to build apps like Zapier. So if you look up Microsoft Outlook का API spec, it is thousands of lines. And we were feeding all this garbage to the LLM, and first shot mein LLM never made an actual API call. It worked like 1% of the time. No testing needed. Put a prompt, it won't work, right? It was that bad. So the next thing we did was, now we had actually dug ourselves into a hole. Because when we the whole point was, if we write less code, we maintain less code, right? So when we got iPaaS, we were like, we're taking a ready-made solution and building on top of it. But the problem is now you can't do anything to that solution. It comes with its own problems, and there's nothing you can do about it. So now we had to solve the problems in iPaaS from outside of it. We wrote a multi-turn evaluator optimizer agent. So this was around November last year, when it would tell LLM something, LLM would say aisa karo, it would do it, it would give result back to LLM, and we would keep critiquing the outputs until we got to the thing. We were spending way too many tokens because we hadn't actually solved the context problem. We were just like, jab galti hoga usko sudharenge, right? So, and the thing is, if you do it next time, it's going to go through those same 10 cycles again. The problem is our AI was not AI enough. It was not learning from its mistakes. ऐसा कुछ भी नहीं हो रहा था, right? Also, we replaced function calls with tool calls. Again, essentially the same thing. Function calls is just calling functions in your code, and tool calls is a semantically more appropriate word, which would mean you can call any tool, not just the tool in your code, right? So we tried to improve our orchestrator agent even better. So we used a library called CrewAI, some of you might have heard of it, to separate it into smaller agents. So Microsoft के सारे apps एक agent, Google apps one agent, stuff like that. And we also did something we started calling schema subsetting. So if it's a big useless schema based on user's prompt, we first use small language models to reduce that schema into something more useful and then give it to LLMs, right? So we got like multiple agents talking to each other, and started reducing the schema. Now this was still a huge problem, and I think we had hit a ceiling. Ki iske aage we can't improve this system a lot, and it was still not usable. The other problem was a lot of APIs are built such that they are efficient. Matlab, if you want to get the body of an email, you have to first run some searches. You have to get the ID of the email. Each email has a unique ID. And using that ID, you get its body, you decode base64, and then you get the email, right? But if you want an LLM to do it, it has to be simpler. You can't do 3 API calls to find one email, right? So that was the problem with like a system that did not have subsetting. So I took like an entire month to just redesign the system from ground up. So we properly ran some tests, understood all the problems that the system had, and we came up with a new system, right? So this system had a planner and an executor as two separate entities, and this was like in, I think, Feb this year, right? So a plan, and we also created a process flow for solving any task. Koi bhi task aaya, you first get it into the planner. It would do some intent classification ki user ko sach mein kya karna hai. Then for each intent, it would create dependencies. So the problem with not creating proper dependencies is, if I say send an email to Alan, because that is usually how our test users were putting prompts, ki do this, do that, send email to Alan with no context whatsoever. So if someone says like that, it would just manufacture Alan's email. It would just say alan@example.com and send an email, right? I've sent a lot of emails to random mailboxes when I was testing this, because we only test in production. That is rule number 1, right? So how Planner does it is, it will first break down the task into very logical steps. For each step, it's going to list out what information does it not know. If I need to send an email to Alan, I need to know his email, the content, and what tool to send it using. Maybe I have both Gmail and Outlook connected, right? So it would make a plan, then it would create a dependency graph for the plan, and then it would, so this was event driven, that's why we had a task state. So any task could go back a few steps and continue again. So it would make a plan, create a dependency graph, and hand it over to our executor agents, right? and we had one executor agent per app now, like Outlook का एक, Gmail का एक, Teams का एक वगैरह. If something fails, the information comes back to planner, and it then goes a few steps back in its plan, creates a new branch, and keeps moving forward, right? So now this was, our AI was more AIing, where it was learning from what is happening, and then we also had several other context states where it would remember that this user prefers Outlook or Alan is a contact on Gmail. It would start remembering these details so that in its future runs, it's going to do fewer turns, right? But yeah, iPaaS ka problem we had still not solved. And a very high level overview of the difference between our old system and new system is just this. We made one small change where it would plan and execute, and if the plan is wrong, everything's wrong, right? Here, it goes through several iterations where it keeps learning new things after every iteration, and it keeps improving on its plans. But it also remembers what doesn't work, right? And then we made sure it remembers this per user. All right. Now, our next big problem was the users. So far, every time we've had a problem, we've fixed it by replacing a system or improving a system. So when I suggested to the team कि आप users को हटा दो, they said no. So we had to do something else. What we did was, users often will give you a prompt that has very little information, and then you first have to go to a bunch of apps, run hundreds of API calls to see what they're talking about, and if not, you ask the user कि क्या बोल रहे हो भाई, ये कौन है, right? So instead, what we did was something else. We created this data ingestion layer, which even before you send a prompt, it's going to go to all those apps and learn stuff, right? This sounds like a huge invasion of privacy because it is, but it would just read through all your DMs in Teams वगैरह, जो भी आपके enterprise apps आपने connect किया है, it would just read everything beforehand. So we had to spend a lot of time on the data ingestion layer क्योंकि you want to understand documents, you want to understand audio, video, वगैरह वगैरह, and you would learn it beforehand. Now, every time planner creates a dependency graph that has incomplete information, we would first do a RAG search on it. We would see what is he talking about, and if we can't find that information, we ask the user. But now we've reduced hundreds of API calls, we are saving on a lot of tokens, and this system in general worked better. But RAG has its obvious issues, right? The semantic search in RAG is just, it understands the similarities between language. So if I say something like, what is up in London office, it'll also give me results about Paris because London and Paris are both European capitals, and in semantics, they are both related. So we also added hybrid search instead of RAG. So hybrid search is also RAG, but it will also look for actual keywords so that your results are more grounded, right? And finally, we improved that with a temporal knowledge graph. So knowledge graph doesn't just understand language, it also understands actual relationships between objects. So if I say something like, I like cats, me and cat become closer in a knowledge graph because it remembers things as fact triplets, like Aditya likes cats, something like that, right? So, and temporal because things change, right? Maybe 6 months later, I realize I'm allergic to cats. So I say, I hate cats. So it will remember that the first 6 months I like cats, and then it remembers that I hate cats because things keep changing all the time. So we got a temporal knowledge graph there, and then in a large way, we had solved our context problem. See, what we were trying to do this whole time is giving that LLM the exact right input. And once you do that, it is great at what it does. But until then, you have to jump through a million hoops to actually fix your problems, fix the data you give it to it, so that that one final thing you give to it solves the whole problem, right? So it's just getting there. This we still haven't solved, right? The iPaaS still has a lot of garbage that we could not get rid of. So we got rid of the iPaaS. This is one thing we could get rid of. We finally switched to MCP somewhere around April. MCP also had problems, but MCP is open source, you can make changes to it, so it was easier. So what we did was, we wrote a MCP server generator. Now some apps are maintaining their own MCP services. And what it's important to know is, हमारा पुराना system was like 70% similar to MCP. But now we didn't want to maintain something that is so similar because we wanted to work on what differentiates us. But at the same time, models and the MCP infra was getting better. So we wrote a generator that can generate MCP servers, and within that we built subsetting. Matlab, if it takes 3 API calls and a lot of context to execute a certain common action, then we would subset it where one prompt runs all those 3 APIs and its interface becomes much more streamlined, right? So MCPs have 3 things: tools, resources, prompts. So we use prompts for that. All the common APIs became tools and our RAG became the resource in MCP. So now within 2-3 calls, it can find the right information, run the right tools, and it can also run complicated tools using subsetting. Each of our, so we had those expert agents, right? Each of them essentially became an MCP client with access to some MCP tools. We also built a lot of tools that would help it do things deterministically. For example, if you ask an LLM to give you base 64 of a word, sometimes it will give it to you right, sometimes it won't. But instead you give it a tool that converts it to base 64, it will always do it well, right? So instead of asking it to do a calculation or count the R's in strawberry, you can give it, if you can let it write a small Python program that counts the R's in strawberry. So that is, so we equipped it with a lot of different deterministic tools. We gave it a calculator, base 64 ka converter, JSON ke tools and all that. And it stopped making those stupid mistakes or hallucinating on those things, right? Last problem, MCP auth. So MCP by design is single user. So if you have one MCP client, one person is meant to use it. It makes a stateful connection to the server, and auth is a part of that connection. So we had to re-engineer it just a little bit so that MCP remains stateful, but the auth becomes stateless. So that hundreds of our users can use the same MCP client to connect to or talk to an MCP server, right? So that was the final change we made. And this went into production around June, I think. And yes, our key vault made a hero's return after we stopped using the iPaaS. So yeah, I think this is the final system we landed on. We're making some improvements to it, but they have around 15 enterprise companies using this, and it is slightly better. So I would say we have a lot of testing. So for testing it, we have very atomic tests. All of them are integration tests, but we have very atomic tests where you can write some commands and expect it to use certain tools, right? So we did that. Then we used LLM to evaluate certain tests. And lastly, our users are also our testers, right? So they keep telling us what's happening and we keep fixing it. All right. Can we learn anything from this? The first few learnings are not very relevant to this example, but working across some companies and industries, I realized there are some patterns we can see, right? One of the first things is a lot of people think if I want to build something using AI, I need to inference a model. Maybe in 10 years that is true, like you can tell a model what to do and it does it, but today that is not the case. You have to treat it more like it's a technology and build with it. Same principles apply. It has to be repeatable, maintainable, scalable, composable, all of it, right? Next is, this example was like LLM heavy, but in our data ingestion and a lot of places we did not use LLMs. But there's a lot of places where problems are solved much better. The price to performance ratio is much better when you use other models, right? LLM is not the answer to everything. So if you're doing something like audio transcription, analyzing images, classifying stuff, there are much more focused models which will save you a lot of time and money. Just use those, right? But it seems like people are using LLMs for everything. They're great at some things, but they are very costly and slow for other things. Yeah, treat it like a technology. What I mean by that is just inferencing a model, prototype banaya, nahi chala, and then you say LLM is garbage, is, I think, a little misinformed, right? When you treat it like a technology, you make sure that, see, LLMs are also a piece of technology where they're trained on a certain kind of input. So if your input is close to its training data, it's going to give you great results. Otherwise, it won't, right? So when you treat it like a technology, you're going to take care of all those other things as if you're building an actual piece of technology and solve those problems instead of spreading misinformation, I guess. Next is different skill set, right? So if you're a company that is building something very specific, like we used to build games. So if you're building games or WhatsApp bots or a social media app, you can't repurpose your existing engineers to do this, right? Because it's a different skill set. They either have to upskill or you need new people or something else. But I see a lot of teams building internal teams to do this. And if your engineers are able to upskill, that's great. But see, in 2008, we had web dev. Most people were building websites, I guess. and app development started around that time, 2008 to 2010. It's not like the web dev was asked to write Android and iOS apps, right? They got a new team for it, or their existing people upskilled. So same thing applies here. It's a different skill set and often different from your company DNA. So if you are a company that is building something specific like games, why are you spending your time building an auth server? Why are you building your own Kafka, right? You should not do that. Or if you do that, you have to be someone like Google who has a lot of disposable income. Um, Next, emerging tech keeps evolving. So if you look at this example, we had to solve our problems by adapting to whatever how the market is moving, right? So in this example, if we hadn't done that, either our product wouldn't have been as good or we would have just trashed it. So you have to keep up, and because the industry is immature or less mature right now, things are going to keep changing as everyone figures out how this works, and you have no option but to keep up with it if you're serious about it. Next point is decision makers forget that technology evolves. So when we started this 1.5 years ago, I think there were some more people who were trying to build something like that, where you um, tell it to do something and it does it, right? And it's like Jarvis. So I think if we had stopped after our first 2-3 prototypes or first 2-3 trials, as tech evolved, we wouldn't have kept up with it, because most people are like, it can't do this now, and they just assume that is also going to be the future. Abhi nahi ho sakta to 10 saal baad bhi nahi hoga, and that is not true. So decision makers, so whoever starts this today is at least 6 months behind, right? If you want to build something like this, because we've done 1.5 years of work on it, and we took into account that as we improve, our technology improves, the ecosystem is also going to improve, right? And we kind of bet on the ecosystem when we build this product. For technical people, what this means is don't wrap too tightly around tech of today. So if you're building an emerging tech, you should not wrap too tightly. You should have a system that where you can remove individual pieces and replace it with something better. Last thing I did not tell is this company is European, their clients are European. So, and you saw how much private information this thing actually pulls in, or business information, right? So we had to jump through a gazillion hoops to get different certifications so that a client would take a call. And in that, what you realize is the low-hanging fruit in AI is not private. Like most, you'll have to use third-party APIs. A lot of them will tell the truth about keeping your data, and others won't. But we had to jump through several hoops to actually get most of the important things running private. And that was also a huge reason it was hard to do, right? All right, we're going to summarize it a little bit more, right? So uh, addressing FOMO, right? If you're thinking about whether AI is useful to me, think of it like a technology versus thinking of it like a buzzword. So does it save my time? Does it save me money? And does it unlock opportunities for me? If it does neither of those and you've researched well, then it's not useful to you, right? But if it can do any of those, then it is useful for you. I think that is how we can think about it. And the other thing that I've learned is adoption right now, or adoption for emerging tech in general, is always broken because it keeps changing all the time. Existing teams are generally not equipped. Like if you have a Java engineer, they know Java really well, but unless they are really willing to upskill, they will not be able to do this properly, right? And it's not private. So I'm going to oversimplify it a little bit more. So what that translates to is you have to definitely spend time and money to potentially save time and money. And when I looked at this, um, I thought this was similar to R&D, right? Because that's what R&D means. You have to invest your time and money at a chance of saving it in the future, right? Um, and a lot of teams, I understand, it's going to be hard for them to do it because budgets are tight, and then you have to show ROI on everything month on month, quarter on quarter, and it's actually hard. Okay, so last part of my presentation is something new I'm building that I think is relevant. So I'm going to spend 2-3 minutes talking about it. So um, I was thinking, how can we solve this problem? Because everyone across industries, if you're doing audio transcription, maybe you want to generate meeting notes or whatever else you want to do, right? Audio transcription in general uses the same framework, right? Regardless of your industry. So what we've been working on is templating useful tools. So whether you're building this meeting notes thing, or you want to transcribe different phone calls or something else, or you want to analyze images, build MCP agents, a lot of it can be templated so that you only work on your business use case and the rest of it is already done, right? So what we've started to maintain slowly is hundreds of AI tools and features, and they all run on existing open source models. Now, not everything uses LLMs because not everything has to, right? So what it looks like from developer experience perspective, is you tell it what to do and it does it, right? So maybe you want to do image search, maybe you want to implement Face ID in your app, or you want to implement speaker ID or anything else. You want to label images, right? You ask it to do and it does it. I'm calling it Project W because we haven't thought of a name yet. Suggestions welcome. So how it works underneath is when you give it a task, it figures out the right models that can perform that task. It's often multiple models and it completes the task, right? So this is an example of an audio transcription engine we built. It has multiple components, but the purpose of this diagram is to show you that it is also modular and composable. So if you want to properly transcribe audio reliably without human in the loop and everything else, you would need several components, but you can enable, disable some of them. And depending on your particular use case, you can use a specific model or a specific tool to do it for you. Like let's say you want to do speaker diarization, right? Like if you want to separate an audio clip into and annotate it with who spoke when, there are multiple models or tools that can help you do that, and you can pick and choose which ones you want. So this is like a template. You can add stuff to it and make it your own, right? Maybe you have different languages. Maybe some language is not good enough, so use 3 models and then you run consensus after it. So this is what we're working on, and how it looks to people using it is you make an API call. Everyone knows how to make an API call. Once you make an API call, it just stays in your system because everything is running privately, and you tell it a task, it uses the right models and it completes the task. So from experience point of view, you select the features you want, then you can customize it based on the compute you have available, what models you have, and then you can do bring your own cloud deployment. Like you can make a private deployment on your own cloud and the whole thing runs for you, right? And you can do this whole thing in 60 minutes. And for reference, I spent like 3 to 6 months with every client architecting and setting up things for them. So what we hope to solve is there's a lot of things that people are trying to do, and about 80% of it is the same, right? So we're trying to template it. So Abhi, it takes around 3 to 6 months to go from an idea to prototype to say production. It's going to take 30 to 60 minutes for you to validate now, right? You would have to upgrade your team and keep that team to maintain this and keep up with evolutions. You won't have to do that. And we are only working on things that run privately, right? And when you do it on your own, it depends on you whether you want it like that or not. Yeah, this is again the back of my business card because I did not make a thank you slide. But yes, that was my presentation. And do we have time for questions or did I cross the time?
We can take 3-4 questions.
Awesome.
I have a question.
Yes, sir.
Do I need a mic? Yes. So very interesting, Jarvis talk and things like that, right?
Thank you.
So one question is that, did you find that the choice of an LLM has an effect on how well the task is done overall? And
Okay, yes, please continue.
sorry, I mean the second part of that is, how does your eval framework look like?
All right. So choice of the LLM has some impact on it. For example, if you're using MCP, right, the newest generation is slightly better at doing MCP because they've been trained with. So MCP also essentially does structured tool calls, but the new LLMs have been trained keeping that in mind. So our eval framework, and it does matter, but not a lot. It's not a deal breaker, is what I would say. So our eval framework looks like, first study the benchmarks thoroughly because there's a lot of people running a lot of benchmarks, and we do that. Then once we shortlist some models, we're going to then have our own benchmarks. So we had a data set of several thousand very atomic tasks with the kind of inputs we have, and we would run them. And sometimes we use structured responses to evaluate them, and sometimes we use LLMs to evaluate our own. So a larger LLM to evaluate these responses. But once you've selected this, like I said, it makes a small difference today because there's a lot of good choices. But once you do that, all the other context problem is something is your own problem to solve, right? Like we had to do a lot of things outside the LLM to make sure the LLM works well. So we've been wrapping around mainly Meta's Llama models and OpenAI's models, right? So over time we've gotten used to how they respond, and even our system has gone more in direction of how they work. So if we just try to swap it out with something like DeepSeek, I don't know how easy that would be. But there is a small difference. I hope that answers your question. Yeah.
Just one question.
Yes, sir.
So initially you mentioned that for all the for whatever the query user is typing for your initial presentation, sorry, initial demo which you showed us.
Yes.
Like,
yes.
so did you use the LLM for this intent classification categorization, or it's a feature engineering that people were using earlier?
No. Initially, we were using LLMs for intent classification, but finally, when we got that whole process flow right, what the process flow helped us do is break down any problem into the same steps.
Okay.
That is what process does for everyone. Like if you have if your company has a bug report ka process, bug report आता है, ऐसे file होता है. We had a similar process. We still do intent classification, but it's just three things. Is it small talk? Is it a retrieval question? Or is it a task?
Okay.
And for that, finally we used we fine-tuned Roberta. Roberta karke there is an encoder-based model.
Twitter ka probably.
Yeah, I don't know who's worked on it.
Okay.
I'm sorry about that. But we used the final thing has Roberta, but before that we used to use like I think an 8 billion param model to do that classification.
Okay.
We can take one last question.
Okay. Yeah. So thanks for this talk. So I want to understand about the way you are trying to bring some determinism in the output.
Right.
Because I kind of burnt my fingers while doing this, and like since I'm working in an enterprise as a developer, we have a clear mandate. We will not build any tool. We will use. So maybe there are teams because, and like you said, like budgets is a concern, and since I'm trying to use it, so like I can see that maybe say let's say agents.md, things like the directives that we give that can bring some kind of determinism. But apart from that, have you seen like can you tell some best practices, or like from your experience, is that something like this works and something like this doesn't work?
So a complex query in our system would make anywhere around 30 to 40 LLM calls. So depending on how complex your query is, and in that, not more than 2 queries will do an unstructured response. All our responses are very tiny. We've broken down a big problem into very tiny problems. So the LLM itself breaks it down. So we have several stages to it. Later maybe I can show you some of the design, but it has several stages to it, and each stage is very objective. So the answer is almost always an enum or a boolean or something like that. Very, very objective, because when you're building with traditional tech, that is what you need, right? You need those data types. So almost all our answers were almost always an enum or booleans. And if it has to pick a tool, it is instantly validated. Did it pick it right, or you just go through it again. And the only place where we use these things is for generation tasks. Like let's say you ask them to write an email, right? Then it'll understand the user's writing style, understand the user's signature, and then write an email. Now this is kind of unstructured. Is maybe we ask it to ask it for a structured response, but the email body is unstructured, obviously, or while formatting the final response, right? Those are the only two places we let it go, say wild or free. Everywhere else, it very, very tiny tasks. We break it into very tiny problems, and it solves each problem very well. That is what we came up with in the end.
Okay, fine. Thank you.
Yes, awesome.
All right. Thank you, Aditya. All right. Also, thank you all for staying through. We'll now open for a short 10-minute break. Okay, and we'll reassemble for our third speaker.